Hi guys, in today's lesson, I'll be solving some jam likely related question on stoichiometry with us, and I want you guys to stay to the end of this lesson. If you have not watched my previous video on stoichiometry, I want you guys to watch my previous video. So let's start with the first question of the day, and the question says a reaction requires 0.2 moles of calcium carbonate, which happens to be CaCO3. And the question says, what is the mass of CaCO3 required? Now, if you look at this particular question, the question says that a reaction requires what? 0.2 moles. 0.2 mole of what? Of calcium carbonate, which happens to be what? CaCO3. Now, what is the mass? Now, the first thing is to know what you are looking for. In this particular question, we're being asked to find what? The mass. If you look at it very well, the question says what? What is the mass of what? Of CaCO3. And CaCO3 happens to be what? The compound that we are working with in this particular question. And if you also look at this question very well, we are giving moles, 0.2 moles of what? Of calcium carbonate. So we're giving moles in this question. So it will be moles equal to what? 0.2. So we're giving moles in this what? In this question. And then the main question says, what is the mass? So in this question, we're looking for what? We're looking for mass. So mass equal to, we don't know, because that's what we're looking for in this particular question. Of course, we're giving mole, and then we are being asked to find mass. Under stoichiometry, which relationship relates mole and mass together? It is the mole and mass relationship that relate what? Mole and mass together. Now, under mole and mass relationship, we have mole to be equal to what? Mass divided by what? By your molar mass. Molar mass. Now, in this question, we're giving what? Mole to be what? 0.2, and then they are asking us to find what? The mass, which we don't know yet. And then we are going to look for molar mass first before we able to look for what? For this mass. And then we need to use this compound, which is CaCO3, that they gave us in the question, to find what? Our molar mass. So molar mass equal to, now we're going to use this compound, which happens to be calcium triacarbonate 4, which happens to be what? CaCO3, to find what? Our molar mass. So now calcium, they gave us here to be what? 40 plus carbon here, they gave us to be what? To be 12 plus oxygen to be what? 16. But don't forget, in the compound, oxygen has a subscript here, which happens to be what? To be 3. So that was 16 times 3. Now, this subscript is only for the oxygen. Please take note of that this subscript is only for the oxygen. Assuming we are having brackets here, then we cannot say this subscript is for everything inside the bracket, because the subscript, which is this 3, is outside the bracket, which means it's for everything or all the elements that makes up this compound inside the bracket. But now there's no bracket, so please take note of that. Take note of this rather. So there's no bracket here, and this 3 is after the subscript closer to this what? To this oxygen, which means the 3 is for what? It's for only the oxygen. So it's not what? 16 times 3. Now, we're not going to what? Solve out everything. So then 40 plus 12 plus 16 times 3. We're going to evaluate this one first. So 16 times 3 will give us 48. So it's not what? 40 plus 12 plus 48. So if you add everything together, you're going to get 100 gram per mole. Don't forget. So the unit for what? For molar mass is what? Gram per mole. Take note of this. So this is not our final answer. This is just for what? For the molar mass. Now, having gotten our molar mass, we'll now impute into what? To this formula. Now, we're not going to use this formula to now solve for what? For our mass. So now, number of moles, the mole they gave us is what? 0.2. So it's not what? 0.2 equal to, we're looking for mass. So mass divided by what? Our molar mass. Now, our molar mass is what? Is 100. So which was we calculated here earlier. So not what? Divided by what? 100. Now, at this point, see there's equality sign here. What we're going to do is to what? Is to cross multiply. So we are going to what? Cross multiply. So there's over 1 here. Now this mass will times this one down, then 0.2 will times this 100 here. So that's what will happen. And of course, mass times 1 is as mass. So mass equal to now 0.2 times 100. So 0.2 mass is now equal to what? 0.2 times 100. Now please take note that 0.2 times 100 is equal to what? 20. 20 what? Gram. So gram is the unit for what? For mass. So our answer is what? 20 gram. Don't just calculate it here. Now of course, we are giving option. Option A says 10 gram. Option B says what? 20 gram. No need to go to option C and option D again, because option B is what? 20 gram, and the answer we got is what? 20 gram, which means option B happens to be what? The correct answer for this particular question. So 20 gram is what? The answer for this question. So moving on from here, we'll be moving straight to the what? To the next practice question of today's lesson. So the next question says a solution contains 0.5 mole of hydrochloric acid in 250 cm cube of a solution. What is the concentration of the solution in mole per dm cube? Now if you look at this particular question very well, now the question says what? A solution contains what? 0.5 mole. So in this question, in this particular question, we're giving mole, 0.5 mole of what? Hydrochloric acid. So the acid here we are working with is what? Hydrochloric acid, HCl, in 250 cm cube. So, and of a solution. And the main question now says, what is the concentration? So we are looking for concentration in this what? Particular question. In what? In mole per what? Per dm cube. So this particular question, if we must find the concentration must be in what? In mole per dm cube. And now if you look at the options they were even given, they were given in what? In mole per what? Per dm cube. Which means this dm cube is a what? Is a unit for volume. So the volume must also be what? In dm cube. But if you come back to the question, the volume that they gave in this question is the what? Is a cm cube. Which means we must do conversion for this volume first, even before even calculating our what? Our concentration. If not, we will not get the what? Correct option. Now, having explained this question, let's now bring out our parameters before what? Tackling this question. Now, we're giving what? Mole. So mole is equal to what? 0.5. 0.5. So our mole is what? Is 0.5 of the hydrochloric acid in 250 cm cube, which means our volume is equal to what? 250 cm cube. Now we cannot work with this 250 cm cube because the question says what is the concentration of the solution in mole per dm cube. Now this mole is the unit for what? For this mole they give us, and the dm cube the unit for what? For the volume. But the volume they give us here is the cm cube, which means we have to convert from this cm cube to what? To dm cube. Now a converted volume from cm cube to dm cube, you simply divide the value that they gave you in cm cube by 1000. So that's what we're going to do here now. So it will not be what? 250 cm cube divided by what? By 1000. But if you are given volume in dm cube and then you want to convert it to cm cube, you will multiply the volume that they give you in dm cube by 1000. Then you will not get a new volume in cm cube. But in this case, we are being given volume in what? In cm cube. And then we need to what? Convert it to what? dm cube, which means we are going to divide the value for the volume they give us in cm cube by what? By 1000. To get our actual volume in what? In dm cube. So that's what we're going to do here right now. So it will not be what? 250 divided by 1000 is equal to what? 0.25 dm cube. So this is what our volume in what? In dm cube. Now having gotten this, now let's now calculate our concentration, because concentration we're not given the question. So this is the half form for concentration. So we are not giving the question. So we're looking for what? For concentration. Now, the formula we're going to use for this particular question is, please take note of what? Of this formula. The formula is what? The formula is what? Mole is equals to what? Concentration times volume. So this is the formula we are going to use for this particular question. Please, if you have not watched my previous video on stoichiometry, I want you guys to watch that my previous video, because in that video I gave list of formulas for tackling stoichiometry word calculations, and I also gave various relationship under mode consent under stoichiometry. Please, I want you guys to watch that video to get more updates and more information about stoichiometry formulas. So let's continue with what? With this question. So the formula we're going to use for this particular question is what? Mole equal to what? Concentration times what? Times volume. And then we are looking for what? Concentration. But we already have value for mole, and they already have value for what? For volume. Now I'm not going to impute it into what? This formula. Now, so our mole given the question is what? 0.5. So to what? 0.5 equal to concentration, which we are looking for, concentration, times volume in dnq, because converting it from cnq to what? Dnq. It's another what? 0.25. 0.25. Now what we're going to do is to what? What we're going to do from this point now is to make this concentration the subject of what? Of the formula. Now concentration times 0.25, you get concentration 0.25, because we're going to multiply everything here first. So it's not what? 0.5 equals to what? This concentration times 0.25, same thing as 0.25. Now what we're going to do here now is to divide by the coefficient of what? Of this concentration, which was 0.25. Now we're going to divide both sides by it. So now be what? 0.25 divided by what? 0.25. Then here also 0.25. So that's what we're going to do. Now this 0.25 down, subtract this 0.25 up. Now what is remaining here is what? Concentration. So therefore concentration, this is short form for concentration. So concentration equals what? 0.5 divided by what? 0.25. So this is what we are going to do now. So of course 0.5 divided by 0.25, you get what? 2 what? 2 mole per dm cube. So these are what? Our final answer for what? For this particular question. Now the formula we use for calculating this particular question is what? Mole equals to what? Concentration times what? Times volume. Now our mole given to us in the question is what? 0.5 equal to what? Concentration times what? 0.25 for our volume. Now we got it what? In dm cube. Now to not be what? We're not going to divide both sides by what? By the coefficient of what? Of this concentration, which happens to be what? This volume, which is 0.25. We're going to divide both sides so that the concentration can be what? Alone. Now, so it's not to not be 0.25 divided by what? 0.25, then 0.5 divided by what? 0.25. Now this 0.5 then subtract 0.5 up. Now concentration is now what's remaining. So concentration is now equal to what? 0.5 divided by 0.25, which happens to be what? 2 mole per what? Per dm cube. Now of course they give you option. Option A is what? 0.5 mole per dm cube. Option B is what? 1.0 mole per dm cube. Option C is what? 2.0 mole per dm cube. And we got 2 mole per dm cube. It's still the same thing. 2.0 mole per dm cube, 2 mole per dm cube, see the same thing. So option C happens to be what? Our final answer. So no need to go to option D. So option C is what? Our final answer for this particular question. So option C is what? Is the answer for this question. Please, if you find this class very interesting, I want you to what? To subscribe to my YouTube channel at Divine Online Chemistry Tutorial. Don't forget to like my video. Don't forget to comment, and don't also forget to what? To share my videos. So let's continue with what? With the lesson. So from here, we'll be moving straight to the next practice question. So the next question says, what volume of oxygen gas O2 is produced at STP when 32 grams of oxygen gas is produced? Now if you look at this question very well, the question says that what volume? So we're looking for what? For volume. What volume is what? Of oxygen gas is produced at STP when 32 grams of oxygen gas is what? Is released. Now we're also giving what? Mass. And the mass we're giving is for the mass of the oxygen gas released. And the volume we're being asked to find what? Is for the volume of what? Of same oxygen gas. Now under stoichiometry, which formula are we going to use to find what? Volume at what? At STP. Now the formula we're going to use is what? Please take of this formula. The formula is what? Mole equals what? volume at STP divided by what? Molar volume. By molar volume. And please take note that molar volume has a value which happens to be what? 22.4 dm cube. So in dm cube, the value is what? 22.4. But in cm cube, the value is what? 22,400. So in cm cube, the value is what? 22,400. So please take note of what? Of this. So this is the formula will be what? Will be using for this particular question. Number of moles was volume at STP divided by what? By molar volume. And they were being asked for find volume of what? Of oxygen gas. And then, but if you look at the question very well, we're not giving moles because there's nothing like mole in this question. Because the question says what volume of oxygen gas, which is O2, is produced at STP when 32 grams of oxygen gas is what? Is released. So there's nothing like mole here. But we can find mole using this formula. Mole equal to what? Mass divided by what? By molar mass. So this formula will be able to find what? Our mole first. So now we're going to find our mole first. Now in the question, which mass did they give us? 32 grams of what? Of oxygen gas. So the mass they gave us in the question was 32 grams of what? Of oxygen gas. So equal to what? Equal to what? 32 divided by what? Now our molar mass, we're going to what? Use this O2 to find what? The molar mass. Now oxygen is what? 16. They give us the question. So oxygen is what? 16. This is what? 16 times 2. Now 16 times 2 same thing as 32. So equal to what? 32 divided by what? By 32. Now 32 divided by 32 is what? Is 1. So equal to what? 1 mole. So our mole time is now what? Is 1. So please take note of this. Is now our final answer. This is for the mole. Now having got our mole, we are going to substitute this value for mole into what? Into this particular question. Now please take note that we are not going to use this molar volume in cm cube, because the unit that they give us for this particular JAM question, because you can see it's JAM 303 question. For this particular question, the volume is what? dm cube. So I'm going to use 22.4 dm cube, not 22,400 cm cube. Assume the unit were what? Cm cube, would I use what? This one. But just take note of what? Of the two units, of the two values rather, for what? Molar volume. Now we're not going to impute this 1 mole into what? The question. So our mole, yes, is now what? 1. So it's not what? 1 equal to volume at STP. So 1 equals to volume at STP divided by what? 22.4 dm cube. Now what we're going to do here is what? Cross multiply. We're going to cross multiply, so over 1 here. So now what? Volume at STP times 1 equals to what? 1 times 2.4. So therefore, volume at STP times 1 is set as volume equal to what? 1 times 1 times 22.4. Now 1 times 22.4 is set as what? 22.4 dm cube. So this is the answer for this particular question. Option A is what? 22.4 dm cube. There's no need to ever go to options B, C, and what? D again, because we got 22.4 dm cube, and then option A is what? 22.4 dm cube, which happens to be what? Our correct answer for what? For this practice question. Now from here, we'll be moving straight to what? To the last question of today's lesson. Please don't forget to like my video, to comment, and what? And also what? To share my video. If this is your first time what? Coming across my what? My videos. So let's continue and let's produce the last practice question of the day. So this question says calculate the number of moles of calcium chloride, which happens to be what? CaCl2. That can be what? That can be obtained from 25 grams of what? Of limestone, CaCO3, in the presence of what? Of excess hydrochloric acid. Now, if you look at this question very well, now this question is a bit complex under stoichiometry calculations. Now, if you want to calculate this question, the first thing first is to what? Is to balance a chemical equation. That's the first thing first. Now, what are the compounds that we're giving the question that are going to use to balance the equation? Now, the question says calculate the number of moles of calcium chloride that can be obtained. Now, since they wrote here that can be obtained, it means there was something or there was some element that went into reaction that leads to this calcium chloride as part of the product that was being formed. Now, the compound that went into reaction are, because the question says that can be obtained from 25 grams of limestone, which means limestone, which happens to be CaCO3, went into reaction in the presence of what? Of excess hydrochloric acid. So it was this limestone, which happens to be CaCO3, and this hydrochloric acid that went into reaction at the reactant side to form the product. And of course, this calcium chloride was one of what? Of the product. So we're going to balance the equation first. So now be what? CaCO3 plus hydrochloric acid HCl. Now, please take note of this. When balancing chemical equation, you see this triisocarbonate is an acid radical. Please take note of this, that triisocarbonate, which happens to be CO3, is an acid radical. And the charge of this CO3 is what? 2 minus. Please take note of this. Now, what I want you guys to take note of is this. Now, you see this triisocarbonate, anytime it's reacting with any acid at all, be it hydrochloric acid, be it tetra or sulfuric acid, any acid at all, as far as it is reacting with an acid, please take note that a gas must be evolved at the product side, and that gas is what? CO2, carbon dioxide. So please take note that any triisocarbonate is reacting with any acid and is reacting with any acid at all at the reactant side. Please take note that CO2, carbon dioxide, is always being evolved at the product side. So now, please take note that other product that will be formed will be, you see this calcium will now react with what? With this chlorine. So now the product form here what? CaCl. Calcium is 2 plus, chlorine is what? 1 minus. And then we'll need another atom of chlorine to make it what? 2 minus. So we now have to put 2 here, which means we now have 2 atoms of chlorine here. 2 minus, 1 minus, and another 1 minus. 1 minus 1 minus is equal to what? 2 minus. Now 2 plus 2 minus is equal to what? 0. So which means here is what? Balance. Plus CO2, which is the gas evolved, plus H2O, which happens to be what? Water. Now, chlorine is now what? Ca2. We now have 2 atoms of chlorine here. And then which means we need to also have what? 2 atoms of chlorine here to make this equation to be what? To be balanced. And then we have what? 2 atoms of hydrogen here. We only have 1 atom of hydrogen here. So we need to also make it what? Balanced. So what we're going to do here is what? Put 2 as a mole here. Now, this 2 is for what? Both the hydrogen and both the chlorine. Which means we have 2 atoms of hydrogen here, 2 atoms of hydrogen here, 2 atoms of chlorine here, 2 atoms of chlorine here, which makes this equation to be what? To be balanced. If you cannot balance chemical equation, please, you don't have any business stoichiometry calculation, because it will be very difficult for you. In one of my previous videos on my YouTube channel, I taught you how to balance chemical equation. Go watch that video to get more updates and more information on how to balance chemical equation. So let's come back to what? To this lesson. Now, having balanced this chemical equation, now please take note that before you can calculate stoichiometry questions like this, you must have to find the 2 compounds that you'll be using for questions what? Like this. Now, if you look at this question very well, the question says that calculate the number of moles of calcium chloride. So I calculated the number of moles of this calcium chloride, this one. Then we need to now find the other one that can be obtained from 25 grams of what? Of limestone. Now the mass of limestone was given, and limestone was CaCO3. So CaCO3 happens to be the second compound they will be using. Now, having located the 2 compounds, what we're going to do here is what? Find the molar mass of what? Of the 2 compounds. Calcium is what? 40, as given in the question. So it's what? 40 plus carbon is 12 plus oxygen is 16. Don't forget there's 3 here times 3. So everything will be equal to, now, so everything will be equal to what? 40 plus 12 plus, now 16 times 3 is what? 48. So our final answer is equal to what? 100 gram. Are you seeing it now? You see it now? 100 what? 100 gram per mole. Don't forget, 100 gram per mole for what? For the calcium carbonate. Now, let's now come forward for the, okay, let me put it here because space, what? Equal to what? 100 gram per mole. So please take note of this. Now, for the calcium chloride, Now be what 40 plus now chlorine is what 35.5. They give us the equation 35.5. So what 35.5. There's sulfate here which is 2, which is times 2. Now it's equal to what? Everything is equal to what? 40 plus now 35.5 times 2 is what? 71. 71 equal to now generally everything now be what? 111 gram per mole. So please take note of what? Take note of this. So we have now calculated the molar mass of what? Of calcium chloride, of calcium carbonate, and of what? Of calcium chloride. Now, having found the molar mass, now the next step will be from the balanced equation. From the balanced equation, 100 gram of CaCO3 is equivalent to what? To 1 gram of what? Of calcium chloride. So it will be what? 100 gram of what? Of this was CaCO3 of CaCO3 is equivalent to 111 gram of what? To 1 gram of what? Of calcium chloride, CaCl2. So this is the first step. Now, it therefore means that 1 gram of CaCO3 is equal to, we're going to do 111 divided by what? By the 100 gram of what? Of calcium carbonate. So now be what? 100 gram. So therefore, how many gram of CaCO3 will give you the question? 25 gram of what? Of CaCO3. So now be what? Therefore 25 gram. Therefore 25 gram of CaCO3 is equal to what? You see this 111. You see this 111 divided by 100. You bring it here again. So now be what? 111, which happens to be 111 divided by what? By 100. Now times, you see this 25. You bring it here times what? Times 25. So equal to, now if you do everything here, now the mass will not get for because if you look at this question very well, we're calculating what? We're calculating mass first, because they told us what? To calculate the number of moles of calcium chloride. We cannot calculate the number of moles of calcium chloride straight away, because the mass we're giving is for what? The mass we're giving for what? Calcium carbonate, which was CaCO3 here. We need to find the mass of what? Of this calcium chloride first, before we're able to find what? The number of moles of calcium chloride, number of moles of what? Of calcium chloride. That's what we are doing here now. So I'm looking for what? For the mass of what? Of calcium chloride first. Because the mass they give, because look at it now, 25 gram of limestone, CaCO3. So we need to find what? The mass of calcium chloride before we're able to find what? The number of moles of calcium chloride. So it is the mass of calcium chloride. That's what we're looking for here now. So these are the processes in finding what? The mass of what? Of calcium chloride. So it's now be 111 divided by 100 times 25. Now, if you evaluate everything here, you are going to get 22. You are going to get 27.75 gram. Are you seeing it now? You are going to get what? 27.75 gram of CaCl2. Are you seeing it now? 27.75 gram of what? Of CaCl2. So I've now got our mass of what? Of CaCl2. Now, let's not go straight to the what? To the main question of the day. What have to be what? Our mole. So it's not be what? Mole. We're not going to use the formula mole equal to what? Mass divided by what? By molar mass, which equals to mass. Now the mass, and you now see the new mass of God for what? For this calcium chloride is what? 27.75. So we're going to use 27.75 divided by molar mass of the compound. This is what you look for. Molar mass of calcium chloride. We calculated it here before, which happens to be what? 1 gram, which 111 gram. So it's what? 111 gram. Now, per mole. Now, we're not going to find what? Our mole. Now, 27.75 divided by what? By 111. We now get what? 0.25 gram. I mean 0.25 gram, because it's mole. So I'm not going to leave it only gram per what? Per mole. So this happens to be what? Our mole for what? For calcium chloride. Because the question says what? Calculate the number of mole of calcium chloride. So this happens to be what our move forward for calcium chloride. The reason why I did not use this mass straight away to just do number of moles mass over molar mass, because the mass they give us here was for what? Mass of what? Of limestone CaCO3. We cannot use this mass. So we need to find the mass of what? Of calcium chloride using what? These processes. So this happens to be the mass 0.25 gram. I mean, this happens to be with the mole, which happens to be 0.25 gram per mole. Now let's now come straight to our options. So this happens to be what? Our correct answer for what? For this question. So with this, we have come to the end of this practice question. If you find this video very helpful, I want you to subscribe to my YouTube channel at Divine Online Chemistry Tutorial. Bye and see you in my next post.